So, hello everyone. I hope you have a nice day. I am Mohammed Hassan, and I will be your instructor for the next 10 to 15 minutes. Basically, today we are going to talk about Arduino in particular and microcontrollers in general. We are going to know the structure of the microcontroller, or what is a microcontroller, the internal components, with very simple analogy. Then we are gonna talk about some of the most common Arduino boards, such as Uno, Nano, and their different applications, also their different features. And finally, we are going to talk about the Arduino programming, whether we are going to use a drag and drop method, or we are gonna or scripting, like typing on the keyboard the words of the programming language. So starting with the microcontroller structure, let's say that the human being is a microcontroller, or the human being is a system. Basically, the human body consists of brain, heart, lungs, stomach, liver, hands, legs, and other organs. Basically, the brain does the mathematical operations, such as how far this bottle from me, or 1 plus 1 equals what, 2 times 5 equals 10, and so on. The heart is the organ that provides the blood to the other organs, and so on. So in this system, each organ or each component has its function or its duty that it must do in order that other organs can work and do their functions. That's exactly what a microcontroller does. A microcontroller is basically a system, just like the human body, but it consists of electronic components, not organs. For example, the microcontroller brain is something that's called microprocessor. This microprocessor can do arithmetic or mathematical operations, such as multiplication, addition, subtraction, or division. The other organs of the microcontrollers are not called organs, they are called peripherals. Remember that expression, but we are not going to use it a lot, especially in this stage. Maybe later we can use this terminology, peripherals, but we are gonna name it tools or features. For example, the brain of the microcontroller is called the microprocessor. This brain does, as I said, the mathematical operations such as multiplication, addition, division, and subtraction. But with the help of the other peripherals, it can do more complex or more complicated functions or instructions. The main peripheral or the main tool of the microcontroller is called digital input output, or digital pins. They act as the hands of the microcontroller, as they might blink a lid, or shut down a lid, energize a lid, energize a motor, and so on, or it can receive data from sensors and so on. But in digital form, which means binary form, and this topic we will cover later. Another hand, or let's say legs of the microcontroller, is the analog pins. It does the same function as the digital pins, but with other sensors, or other type of sensors, or other type of motors. For example, we have the power supply, which is considered as the heart of the microcontroller, as it supplies the other organs with current. And for example, we have an oscillator which basically produce a repetitive waveform or a repetitive output, which mostly it's a square wave that's used for timers, counters, and so on. But we are gonna concentrate mainly on the brain of the microcontroller, which is the microprocessor, the hands and the legs, and the heart. Other components would be in some advanced levels. So as we mentioned before, the microcontroller system consists of a microprocessor and peripherals. These peripherals can be more than five. It can be hundreds and hundreds of peripherals. Maybe analog to digital converter, which is converting the type of sensors that called analog sensors to digital waveform, or the type of signals that's called waveform. We have timers that we can use to calculate the time, counters to count, which means when I have something that I can increase the count by 1, 2, 3, and so on. Memory to store the code or to store some constants or data, and communication to communicate with the other microcontrollers or other systems, and so on. So these are called the microcontroller structure or microcontroller brain and other peripherals or other components. As for the types of Arduino ports, we will deal with mainly two of them. The first is called Arduino Nano. It's the simplest Arduino board that is produced. It has a very compact design, which means it's small in size and weight. But the disadvantage of this type is that it has limited computing power and limited memory due to its compact size. As I mentioned before, due to its compact design, which means lightweight and small size, it can be implemented or can be used in drones, which are the flying the small helicopters that fly in the sky, and something like Cosmo Robot, which is a very small robot that does very simple tasks and can be considered as a pet, such as a cat or a dog. It does very simple tasks such as interacting with the user. The second type, or the most common type in the market, or that we will deal with, is basically called Arduino Uno. It's as I mentioned before, it's the most common type in the market. It has sufficient computing power and memory. It can calculate very complicated mathematical operations, can carry out very complicated mathematical operations, and its memory is very suitable or sufficient for the small scale applications, which needs which doesn't need very large memory to store the program or to store the system constants. It also has some additional features. As I mentioned before, each microcontroller has peripherals. This type of microcontroller, you can buy some additional peripherals that can be connected with it and use these peripherals, such as it can be connected to Wi-Fi, it can connect it to other devices through Bluetooth, and many other cool features. Some applications of this microcontroller is the robotic arms. It can be implemented to control our robotic arm. Even industrial robotic arms. And the other type, I think you know Amazon Souq and Alibaba and these types of online markets, they use some of these robots, autonomous robots, to transport the ordered goods from one place to the shipping area. So they can be implemented using Arduino and some sensors, some digital sensors, some analog sensors, and so on. So Arduino Uno has larger computing power. It can do more complex mathematical operations, and it can some features can be added to be more powerful, or some peripherals. As for programming, we are gonna use the method that's called drag and drop, which means basically that we can select what we want from a ready list, that we can choose what we want, drag it by the mouse, and drop it in the programming area, and that's it. We can use that method to write a simple code. You can also write a very complicated, not very complicated program, but it's mainly used to get familiar with the programming, or so. It's considered as the inlet to the programming language of Arduino, or C in general. But as for the beginning, we are gonna use this method to learn Arduino and to do some small scale projects. After you have some experience with Arduino, we are gonna translate what we have learned in the drag and drop programming method to the scripting, which is used in the real life, and which will enable you to produce very complicated programs, and do some very cool stuff, such as robotic arms, autonomous vehicles, which we have seen in the previous slides. That was it. I hope you understood what I say.